Okay, this is August 11th, and we're going to focus on the number in front. The other two videos, if we add or subtract at the end, add or subtract inside the parentheses, but this one's multiplying, so we're multiplying by the number in front. This is going to either stretch the graph vertically. Well, if you think of a rubber band, if I had a rubber band, I could stretch it vertically. It would be tall and skinny, you know. If I smushed it down, it would get short and wide. The same thing is true if it's negative. I can reflect. So reflect means flip it upside down. And so sometimes the parabolas can go upside down. So we haven't done one of those yet, so I want to show you all of this stuff. So we're going to start, remember that we always compare to the base graph. Some people call it the parent function. Or the base graph. On the other videos I said base graph, so we'll call it a parent function today. Remember, this is what this one looks like. This one starts right at 0, 0, and then over 1, up 1 on one side, over 2, whoops, over 2, up 4, so this is 1, 2, 3, 4. We could even go over and then up up 9, you know, so I can have my graph continue. I mean, it goes forever. So it's there's nothing special about 4, 5, 6, 7, 8, 9. So way up there and way up there. So this is my normal parabola. Normal parabola. That's where the number in front is 1. The number in front is 1. So, what does that number tell us? Well, if it's a positive number, if the A number is positive, then it tells you that this graph is going to open up. So that means that if A is negative, that means the graph is going to open down. Okay, so let's do one that's negative just so you see. So I'm going to say y equals negative 1 x squared. 1, 2, 1, 2, 1, 2, 3, 4. And now then, we can pick some values just so you show. I'm just not making this up, right? So I can pick some values, and if I say x and then y, okay, so if I pick 0, 0 squared times 0 times negative 1, anything times 0 is going to be 0. So that's going to start in the same place that one started. But now if I pick 1, 1 squared is 1 times negative 1. That goes upside down. What if I pick 2? 2 squared is 4. 4 times negative, that's negative 4. So see what's happening. Instead of going over 1, up 1, and then over 2, up 4, over 3, up 9, we're going over, down 1, over 2, down 4, over 3, down 9, right? And the same thing is true on the other side. Negative 1 squared is positive 1. Remember, positive 1 would be times negative 1 would be that. And negative 2 squared, negative times negative, is positive 4. Minus 1 times negative 1 is negative 4. So I've got my values over here. See, my graph just looks like that. That's what's happening. So if the number is positive, it goes up. If it's negative, it goes down. Now, A has another function, and that is if A is greater than, let's write it this way, if A is greater than 1. So if it's bigger than 1, like 2 or 3 or 17, the graph is going to be tall and skinny. All right, so we'll write it that way. Another way of saying it is that it is stretched. Whoops, I can't spell stretch. Vertically. There we go. And so stretch vertically. I am having trouble with my speller. My speller is broken. It's got it in there. I just can't get it. There we go. Vertically. Now then, something else happens. If A is in between, so if it's a fraction or a decimal in between, that makes it short and wide. You can think of it that way. Which means vertical compression. So it's squished, right? So when the number in front is bigger, it's stretched like a rubber band. Imagine me grabbing a rubber band. Or if it's a fraction or a decimal in between 0 and 1, then it's going to be squished, right? So let's see, can I do one of those? We will get rid of this guy. In fact, we'll do both of those, right? And we have the parent function over here, the base graph, so we know we're always comparing it to that. So this guy is, so now we're going to talk about tall and skinny. So what if I had y equals 2x squared? Well, that's going to make it twice as tall. It's going to be twice as tall as that one. What if I had y equals 3x squared? It's going to be 3 times taller than that one. So what does that mean, 3 times taller? Let me show you. 1, 2, 1, 2, 1, 2. So I've got a graph. I'm picking exactly the same numbers I picked here. So we know that I'm picking 0, 1, and 2, -1, and -2, right? Because we're not sliding it left and we're not sliding it up. All we're doing is stretching it, right? So that means the vertex is in the same place. If I put 0 in there, 0 squared is still 0 times 3. Anything times 0 is 0, so 0 comes out. Now I put 1 in there. 1, I put 1 in. 1 squared is 1 times 3 is 3. So over 1 up 3. Now see, here I went over 1 up 1. This one's 3 times taller because this was up 1, this one's up 3. 3 times taller. And then if I put 2 in there, I put 2 in here, I get 4. 2 squared is 4 times 3 is 12. So I go over 2 up 12, right? Here I just went over 2 up 4. So this one's already twice or 3 times taller. Now the other side is the mirror image of this side. So negative times negative is positive. Positive 1 times 3 is 3. Negative 2 times negative 2 is 4. 4 times 3 is 12. This is exactly this. Now then, this one is tall and skinny. It's 3 times taller than the regular one. Short one, let's see if I can do a short one. I betcha I can. So we'll do a short one right here. And we'll pick something half. That's telling me the compression, it's half as tall as the normal graph. This is the normal graph. This is the base graph, current graph. So the half the size. Well, what do I mean half? That means it's not going to be as tall. And each, so if I say for example 0 is the same, because 0 times anything, 0 is still 0. So that point never moved. Let's do 2, because I see when I do 2 squared, I get 4. So I go up. But here, 2, if I put 2 into my problem, I put 0 in already. I put 0 in, and I got 0 out. Putting 2 in. 2 squared is 4. 4 half of 4 is 2. Go over 2, up 2. And then, 1 would be over 1 up a half. It's 3, go over 3, 3 is 9, 9 by 2, 4.5. No, do that, then it'd be, write it over there. So we can, here, 4.5 is right. And then the other, the same, this is a half, this is a half, this is 2, this one is 4.5. And so, have is a y parabola. It goes on forever, like all of them. It's just bigger. So, if the fraction is negative, let's do one more. If the fraction is negative, y equals negative 1/2. Try 1/2. No, because we've got the whole shebang. Negative turn upside down. And down. So, negative is going to make down, open downward. It's going to look like this. And it's going to be wide. It's going to be upside down, wide, or you compress. And so, we are told that when we 0 n times anything is going to be 0. And if 1 n, 1 times will be 1, 1 that, or 1 squared is 1, negative is going to be negative 1. So my little is right here. 2 n, 4 times half, 4, 2, 4 times negative a half, negative 2. So that would be over 2, 2, over 2, 2. Right? And then what? Well, squared is 9. Half of 9 is 4.5. But what about negative half of 9? Well, that's 4.5. So I go down 4.5. Right there. Right there. Once again, I have wide parabola, and it's open down. And the vertex, because I did right, left to right. So, that's the end of part. And I lost my Turner offer.